Hey there, I'm Irfan and welcome to my channel. Today the paper that I've selected to go through with you guys is paper 1 for AdMath from May-June 2023. So without any further ado, let's go ahead and take a look at question number 1. In question number 1, we are asked to find the period of this function, which is a tangent function in terms of radian. So if you recall, the periods of tangent functions are pi, and if you want to find the period of this function, you basically have to take the value of pi and divide it by the coefficient of the theta, which is half. Therefore, the period is 2 pi. In part B, we are asked to basically sketch the graph from negative pi to pi, and we have to state the coordinates of the point where the graph meet the axis. So there are a few ways actually you can do this, but the fastest or the shortcut here is, since I have -3 here, and as you all know, this is associated with vertical movement. In other words, if it's positive, I go 3 units up. If it's negative, I go 3 units down. And since the original curve of a tangent function looks something like this, which passes through origin, all you have to do is to shift that 3 units downward. But at the same time, I have a value of 3 in front of tangent, which is responsible for stretching the curve vertically. So for that, you need to plug in a point which is my x-axis, and as you all know, on the x-axis the value of y is 0, so I'm just gonna go ahead and equate these to 0. Bring 3 to the other side, divide both sides by 3. I get tangent of theta over 2 is 1. Therefore, theta over 2 should be pi over 4, because this is a famous angle. Tangent of what angle is 1? That's 45 degrees, or pi over 4. Having said that, theta is found to be pi over 2, and that's right here. So you just connect it and make sure you do not pass these two asymptotes. Question number 2. I'm given a quadratic expression and I'm asked to write it in this format, and this is quite a frequent question. If you go through past year papers, you see this a lot. This is a complete square format of the same expression. All you have to do at first, you need to make sure there is no coefficient in front of the x squared term. In other words, you can factor it out. Well, at this point, you got two options. You can either factor it out from all the 3 terms, but that's not really necessary. So what I did here, I just took it out of the first and second term. And then the next step is to take the coefficient of the x term, in this case 5 over 2, divide it by 2 or multiply it by half, and then raise it to the power of 2. And that's going to give me a value which is 25 over 16. And then with that, I'm going to add it and subtract it immediately after my x term. If I have done these steps correctly so far, automatically these 3 terms come out to be a complete square. And all you have to do is just bring the x down, and this number you can refer back to what I've got inside the bracket right here. And then of course the number, the fourth term will remain there. In order to avoid any confusion, I use this square bracket. And then the last step is to basically expand the bracket. So I'm going to multiply 2 back into each of the terms I've got here. So I get 2 times x plus 5 over 4 square. And then you combine these two, and it's going to give you basically the value for b, our constant. And then a, in this case, is 5 over 4. In part B, you are asked to find the coordinates of the stationary point on the curve. However, since the word hence is used, because as you know, there are a few ways to find the coordinates of a stationary point, and the most famous one is taking derivative. But if you've already got the equation of your quadratic in this format, there is a fastest way actually. You can take these two values, which are basically the x and y coordinates of your vertex. If you were to draw this quadratic, basically you would get a parabola which opens upward since the coefficient of x squared is positive, and this is my vertex. And the value of vertex is, if you refer to the formula, it's the negative version of this number, and for y coordinate you just copy paste whatever you have here, and that's my stationary point. In part C, you're to solve this inequality. Again, it's the same expression we're dealing with, therefore I'm gonna use what I found in part A, the complete square version of it, and then I make it less than 15/8, bring the 1/8 to the other side, it becomes positive, and then I get to this point and I have to get rid of the 2. I divide both sides by 2 and I get 16/16, which is 1. And lastly, I need to get rid of the power 2. So I'm going to continue here. You just have to take square root from each side. However, if you recall from your book, if the x square is less than a square, so it's the same as x is less than positive a and greater than negative a. You can refer to this formula as well. Having said that, x plus 5/4 is bounded between -1 and +1. Now all I have to do is to subtract -5/4 from all sides, which results in x being between -9/4 and -1/4. In question number 3, I'm given a logarithmic expression where a and b are both positive, and I have to rewrite it as a single logarithm to the base 10. So what the issue is, the first thing you realize is that this number 3, I have to convert it to logarithm. And according to the definition of logarithm, if this is 3, and of course if the base is 10, so this number here, or the argument of my logarithm, is nothing but 10 to the power of 3, which is 1000, and that's what I wrote here. Also, I need to get rid of the 2, which is in front of my logarithm. According to the formula, you can bring it inside, and that's gonna become the power of my a. Also, same thing happens to -12 here. You can bring it inside. That's gonna be the power of the whole expression 4b squared. And then the next step is to basically combine all 3, but before I do that, I need to get rid of this power. So 4 to the power of -12 is basically 1/2. B squared to the power of -12 is also 1/b. That's why I have the whole thing down here in the denominator. And then I need to combine all of them as it is required. I have to make it a single logarithm. Well, the formula says if you want to combine 2 logarithms, you can do that. If there is addition between them, you can simply take the argument and multiply them together. So I have 3 arguments here. I can multiply them together and get 1000a squared over 2b. You simplify that, 1000/2 is 500, and this is my final answer. In part B, I'm given this logarithmic equation and I'm asked to find the possible values of the positive constant c. I have to give my answer in exact form. What I'm going to start with is to make sure all my logarithms have the same base. So over here, as you can see, the base here is c, but the base here is 3. So it's up to you. You can keep either one that you like and change the other one. So I chose this logarithm. All you have to do is to make the reciprocal of that. So here's the formula. If you want to introduce a new logarithm, all you have to do is to make a fraction So this is my new logarithm. Also in the denominator, I have b to the base c. So that's what I did here. Basically in the numerator, I get 1. So if I do that, I get logarithm of 3 to the base 3 over logarithm of c to the base 3. And logarithm of anything to its own base is basically 1, and there is a 2 already in front. That's why I have a 2 in my numerator. Okay, once the conversion is made, you can introduce a new variable or a dummy variable. So let's call all the logarithm of c to the base 3 to be x. If I do that, I get 2 over x equals to 7 plus 4 over x. I have to multiply everything by x to remove this x from the denominator. I end up with this equation, and then I gather everything on the left hand side, and I get myself a quadratic equation which I can solve. This is moderately an easy one. I can simply factorize it. I get 4x minus 1 times x plus 2. You can use box method or any other method that you like. Basically gives you x to be negative 2 and x to be 1 over 4. However, we're not done yet because x was my variable introduced into the equation. So I'm gonna change it back to logarithm of c to the base 3. Therefore, I get logarithm of c to the base 3 is negative 2, and c is nothing but 3 to the power of negative 2, which is 1 over 9. Also here, c is 3 to the power of 1 over 4, which I have written it here. And that's it. Question number 4. We're given the equation of a straight line. Also, we're given the equation of a curve, and we're told that these two intersect at 2 points A and B. And also point C, which has coordinates of A and negative 8, lies on the perpendicular bisector of line AB. And we're supposed to find the value of A. So first thing first, I want to find out the coordinates of point A and B. In order to do that, you just need to replace all the y's in this curve by 3x minus 11. And after expanding this bracket, you get 3x squared minus 11x equals to 4 minus 3x minus 2x squared. You gather all the terms on the left hand side and combine the like terms. You end up with this quadratic equation, which can be solved easily using factorization. And after that, I get myself two linear factors. Each of them, you put it equal to 0. The first one leads to x equals to negative 2 over 5. The second one results in x to be 2. And after the x's, it's time to find the value of corresponding y's. So you can go back into this equation of a straight line and substitute it there. You could also substitute it over here, but that's not a wise thing to do given the complexity of this equation. So that's gonna give me two y's. You can call this point A, you can call this point B, but we're not done yet because I'm supposed to find the point C, and point C lies on the perpendicular bisector. In other words, it's gonna pass through the midpoint of A and B. That's why over here I've attempted to find the midpoint of A and B. All you have to do is to add the x's and take the average. Also take the average of the y's, and it's gonna give me a point with coordinates 4 over 5 for x and negative 43 over 5 for y. Now I need to find the slope of AB, because in order to find the equation of any line, you need a point and the slope of that line. So the slope is not a very difficult task to do. All you have to do is to use this formula. You make the substitution, and then after performing the arithmetic operations, you're gonna end up with value of 3. However, 3 is the slope of line AB. So let's say this is my line AB, and the slope is 3. But I'm talking about the bisector, which is perpendicular to AB. Therefore, using this formula, which says the product of the slope of two lines which are perpendicular to each other is always -1, I can therefore conclude that the slope of the bisector should be -1/3. And now I can construct the equation of the line of my bisector using the famous formula y minus y1 equals to m times x minus x1. And I can substitute the x and y coordinate of my midpoint, also the slope which I just found, and that's gonna give me this equation. However, you do not need to spend your time and tidy up, make y the subject of the equation. No, all we need to do is to substitute this x and y coordinate which belongs to point C respectively into the equation which I just found. Therefore, that leads in finding the value of A. By doing so, you realize that the equation is quite complex. However, if you multiply everything by 15, you get rid of all the fractions. And then once you tidy up, you get 5 to be -5/A. And finally, A is -1. Question number 5. I have to find the first three terms of this binomial in descending powers of x. Well, this is quite an easy task if you remember the formula for binomial expansion. So if you have a plus b to the power of n, so that the first thing you have to do is to find nc0 and then a to the power of n, b to the power of 0 plus nc1, a to the power of n minus 1, b to the power of 1, and then keep decreasing the power of a or the first term by 1, and you keep increasing the power of second term by 1 while you manipulating this combination, the NCR. So by doing that, I get the first three terms here, but you have to be very careful because my second term is -4/x². As you can see here, I put everything in bracket purposely to make them separate and avoid any confusion. After you apply the law of indices, you get the power of x here to be 20, here 18, here 16. Also, you can use a calculator if you want to find the 10C1 and 10C2, but that's quite an easy task if you recall the formula. And after that, the last step is, of course, to combine the constants and combine the x terms. So you can use law of indices for that as well. Finally, you get this expression. In part B, I have to find the coefficient of x to the power of 16 after I multiply the binomial which I found in part A by this binomial which is raised to the power of 2. I want to draw your attention to the word hence. That means you do not need to start from scratch. All you have to do is to use these three terms which you found in your previous part and just substitute it in terms of this guy here. And for the second binomial, you can just expand it using the famous identity, the square of sum, which is the first term square plus double of their product plus second term square. Having said that, x squared become x to the power of 4. You multiply them to each other, the x squared is gone, and also double it, you get 4. And then second term raised to the power of 4, which results in 4/x to the power of 4. And then you have to ask yourself, how can I get x to the power of 16? So this is quite a delicate task, and this is where the students might make the mistake and miss one term out. So how can I get x to the power of 16? Well, I got x to the power of 20 here. Multiplying that by this guy or here will not reduce the power. However, when I multiply it to this guy, the power drops to 16, as you can see here. And then also when I take the middle term and multiply it by this guy, I get x to the power of 16 as well. And the last way to get x to the power of 16 is when I multiply the third term by the first term from my second bracket. And that also results in 720 x to the power of 16. You just add the coefficients and that's gonna give us 564 as the coefficient of x to the power of 16. Question number 4. I'm given a diagram of a circle with center O, the radius R, and I'm told that the area of a minor sector OAB is 25 centimeters square, and the angle of AOB is also theta, and that's in radians. I have to find an expression for the perimeter P of this minor sector in terms of R. The perimeter is nothing but OA plus OB plus the arc AB. Now I have the value of OA and OB because both of them, they are basically the radius, and that is 2R, plus, if you recall the formula for the length of an arc in radian, it can be obtained by multiplying the radius by the subtended angle, and that is R theta. However, since they ask everything to be in the word of R, I have to get rid of theta, and that's where this piece of information which was given to me comes useful. The area of a sector is half of theta R squared, and in this case it's 25. You multiply both sides by 2, you get theta R squared is 50. I want to make theta the subject of the equation. However, since I want just R theta, you can make a wise move here and just remove one R and bring it down to the other side. So you get theta R is 50 over R. So this whole thing, R theta, I replace it by 50 over R, and that's the perimeter in terms of R. In part B, I'm told that R can vary, and I have to show that P has a minimum value and find this minimum value. So I have written the perimeter again, which I found in terms of R in previous part. I'm just gonna go ahead and take derivative with respect to R. Derivative of 2R is just 2. You take the coefficient, and for 50 over R, if it's difficult for you to do that, it's always a good idea to rewrite it as a negative index. Just bring R up and make the power negative. Now you can take the power down, put it in front of 50, becomes negative 50, and subtract 1 from the existing power, which becomes negative 2, and you can take it down again and make it positive. And this whole thing, I'm gonna put it equal to 0, because if you want to find the minimum value or maximum value, basically we're talking about stationary points, and the stationary point are found when the derivative, the first derivative, is equal to 0. By doing so, I'm gonna make R the subject of the equation, and I get R squared is 25. You take square root from both sides, which gives you positive and negative 5, but the negative value is rejected because we're talking about radius, and radius is length, which is always positive. Now that I have to find the minimum value, I have to go ahead and take second derivative. This is basically to show that this is a minimum point. So taking second derivative results in 100 over R3. Basically the 2 becomes 0, that's just a constant. And for this guy, you can also bring the R square up, make it to the power of negative 2. Do the same thing, negative 2 goes in front, become with 50 become positive 100. You subtract 1 from the existing power, becomes R to the power of negative 3. You can take it down and make the power to be positive. Now, since we're talking about the R, which is 5, I just found that you can make a substitution, and that results in 4 over 5, which is positive. That confirms that the value for P is minimum, in fact, when R is 5. So now all I have to do is to find the minimum value of P. So you just go ahead and substitute 5 instead of all the r's in the equation you found for perimeter up here, and that results in 20. Question number 7. I'm given a table in terms of x and y's, and I'm also given the equation of a curve which is y equals to ax to the power of b. But then if you attempt to draw this curve in terms of ln y and ln x, you're gonna end up with a straight line, and I have to basically draw that straight line. So since the x and y axis is now in terms of ln x and ln y, I'm gonna extend this table, add 2 more rows, and find the values of ln x and ln y respectively. As you can see, these are the value I just found. And then you can go ahead, find those points, and just mark them on the space provided here for me. These are the red dots are basically the one that I just found, and then you have to draw the best fit line, obviously. So, and I think this is quite an easy task. You just have to make sure the number of points above and below your lines are equal. You pass through as many points as possible, and this is my straight line. In part B, you have to use your graph to estimate the value of A and B. So don't forget that this was the original equation of my curve. Now, since the graph is drawn in terms of ln x and ln y, I'm just gonna go ahead and take natural logarithm from both sides. This results in separating this argument. If you recall, the formula ln AB is the same as ln A plus ln B. So that's what I did here. Also, you can bring the power down, put it in front of ln x. And if you make a comparison basically with the original equation of the curve, the formula, the famous formula, since the x-axis is now ln x and y-axis is ln y, and I got a straight line, so B is nothing but the slope of the straight line that I found in previous part. So all you have to do is just to choose 2 points and plugging into the formula. So what I selected here is the beginning, which is 0 and 1.6, and also 0.9 and 3.8 right here, which I got from the table. You can choose any other points that you like. However, if you're choosing a point that is from the table, I must stop you right there. The reason I selected this point, because it is in fact on the line of best fit line. So you are not allowed to choose, for example, this point. That's going to result in a wrong and incorrect answer. So basically you can find the rise over run, and that's going to give you the slope, which is B. And for for A, which is right here, this is basically my y-intercept. Ln A is y-intercept, and again, if you refer to the graph, the y-intercept is 1/6. And now, if you want to make A the subject of the equation, what you can do here is e to the power of ln A equals to e to the power of 1.6. So the left hand side results in diminishing the ln, and I have A, and e to the power of 1.6 is basically 5. And these are the value for A and B. In part C, I have to estimate the value of x when y equals to 100. Now that I found the value of B and A, I can find the value of x for any given value of y. All I have to do is to make the substitution. But I rather tidy up a little bit, isolate the ln x on the left hand side, and you can also combine these two lns because ln 5 minus ln y can be written as this. You just divide the arguments to each other, and then I have to get rid of the 2.4, divide both sides by 2.4, and I have ln x equals to 1.25. Again, you use the same technique to get rid of the ln. So e to the power of ln x equals to e to the power of 1.25, and that results in x to be 3.49, rounded to 3 significant figure. Question number 8. Question number 8 is about vectors. So as you can see in the figure, I'm told that OA is defined as vector A, OB is B, and point X lies on the line OA such that OX is 3 over 5A. So basically this part is if OA is 5, OX is 3. So, and Y is the midpoint of line AB. Therefore, this would be half of this. Okay. Now I have to find AB in terms of a vector AB in terms of A and B. So how can I go from A to B? You can go from A to O and then go to B. So AO is negative A since OA is A and OB is B. Therefore, I have negative A plus B. And I have to find X, Y as well. So how can I go from X to Y? You can go to A and then go to Y. That's one possible way. Or you can go to O and then B and then Y. Either way should result in having the same answer. So let's start with rewriting XA and AY in terms of A and B. So since OX is 3, XA should be 2, given that OA is 5. And since I'm also moving in the same direction as OA, it's positive, therefore I got 2 over 5A. For AY, however, you have to be a little bit careful. It is half of AB, which I found here. We are moving in the same direction as AB, and so it's just half of the value I found in part A. And then you just have to tidy up, gather all the A's together, and B, I have only one term in terms of B, and the final answer is negative 1 over 10A plus half of B. Now, I'm given another diagram, which is the extended version of the first one. So if you extend X, Y, and OB, eventually they're gonna meet each other at point called Z. I'm also told that YZ is lambda X, Y, and BZ is mu B. So let's see what the question is asked from us. So we have to find XZ in terms of lambda A and B. So from the graph, if you look at XZ, XZ can be written as XY plus YZ. So YZ is already, we're told that it is lambda, and XY, I have already found it in previous part. So what I'm gonna do is write XZ is XY plus YZ. And then since I'm told that YZ is lambda XY, I can factor out lambda. And then I'm gonna left with XY times lambda plus 1. And XY is what I found in part B, which is negative 1 over 10A plus half of B. In part D, I'm asked the same question, but this time I have to find it in terms of A, B, and mu. So I have to choose a different path. How can I go from X to Z using a path which involves mu. So of course I have to go to O. So that would be X, O, and then OZ. I'm being told that OZ is B plus mu B. The reason I wrote it as B plus mu B is because OZ is OB plus mu OB, and OB we already know it's B, therefore you get B plus mu B. You just have to combine the B's together, therefore you get negative 3 over 5A plus B times mu plus 1. And in last part, part E, we have to find the value of lambda and mu. So in previous parts, part C and D, I found the same vector xz in terms of AB lambda and in terms of AB mu. So all I have to do is to put them equal to each other. At first it might look impossible, but you can simply compare the coefficients. You just have to gather everything in terms of A and B. After you expand these brackets, you just make sure all the B's and all the A's are together, and once you do that, you just have to make a comparison between the coefficients of A and B on both sides. For example, the coefficient of A here is negative 1 over 10 times lambda plus 1. The coefficient of A on this side is negative 3 over 5. And that gives me this equation. You make lambda the subject of the equation, you get it to be 5. And then you do the same thing for B. The coefficient of B here is half of lambda plus 1. On the other side, I have mu plus 1. You multiply everything by 2. You substitute lambda with the value that you just found, that is 5. And that results in mu plus 1 to be 6 over 2, which is 3. And mu is 3 minus 1, which is 2. Question number 9. In question number 9, I'm told that there is a particle P which moves in a straight line such that its displacement function in terms of t is this cubic equation. It's already in a format which is friendly to work with. They have already factorized it. In part A, I have to find the values of t for which the velocity is 0. And as you all know, velocity can be obtained by taking derivative of the displacement function in terms of t. If you look at the equation of the curve, it's a combination of basically two functions. Therefore, I'm going to use product rule. So the first function, I'm going to take it to be 3 times t plus 2, and the other function to be t minus 4 raised to the power of 2. So if you take derivative of the first function, it's the coefficient of t, which is 3, and then times the second function untouched, plus the first function, which is 3 times t plus 2, times the derivative of second function. However, the second function, I have to use chain rule in order to take derivative of that. You just take derivative of outside, which means bring the 2 in front, as I did here, subtract 1 from the power, and then multiply by the derivative of inside, which is the coefficient of t, which is 1. And after that, you get this expression. So what you can do is to factor out 3 as well as t minus 4 out, since it is common between the two terms. So once you do that, from the first term, you left with t minus 4. From second term, you left with 2 times t plus 4. And you have to put it equal to 0 because this is my velocity, and I'm asked to find when the velocity is 0. So at t equals to 4 seconds, that's when the velocity is 0. Also at the beginning, when the particle starts its journey. In part B, I'm asked to sketch the displacement versus time graph of P and stating the intercepts with the axis. So I already know that in time 0 and in 4 seconds, the velocity function is 0. And velocity function is basically my maximum and minimum of my displacement function, because those are the points where the derivative is 0. So that's going to be at the beginning at time 4. So there are two ways actually to determine that. You can either plug in the points just like what I did here, for t equals to 0 and t equals to 4. Also, you can take a look at the original equation of the curve, which is a cubic, and if you expand just the first term, you get 3t cubed and the rest of the story. So the coefficient of the leading term is positive, and since it's cubic, it looks like this. If the coefficient was negative, it would be the other way. So that's also another way to make sure the graph looks like this. And of course over here I plug in the maximum value for t, but that's not really necessary. I just did it to make sure roughly where should I stop my curve at what height basically. And that's it. In part C, I'm asked to sketch the velocity versus time graph. And if you recall from part B, this is the equation for velocity. And this is obviously quadratic curve. It is obvious that the leading term, the leading coefficient is 9. Therefore, my parabola should open upward, as you can see here. And I have a minimum value, but since I'm not asked to find the minimum value, I just have to show the intercepts, which are at 0 and 4, as I found in part A as well. Those are the time where the velocity is 0. Of course, as usual, I plug in the maximum value of my domain to get the final point. In part D, I have to find an expression for the acceleration of p at time t. So acceleration can be found by taking derivative of velocity function with respect to time. And as you can see here, if this is my velocity function, which is 9t squared minus 36t, so if you take derivative, you get 18t minus 36 as stated here. And lastly, I have to sketch this acceleration versus time graph for particle p. So obviously this is a straight line, and all I need to do is to find my intercept by taking t to be 0 and then find the corresponding value for a, and another time make a 0 to find the corresponding value for t. And those are negative 36 and 2. And of course, lastly, I put the maximum value of my domain, which is t equals to 5, to find out where I should stop. However, that's not necessarily because they just want you to find the intercepts. Question number 10. I'm given a trigonometric identity which I have to prove. So usually the approach here is to start from one side and work your way to the other side. So since the left hand side looks more complex, I'm going to start with left hand side. And as you can see, this can be written as cosine squared theta raised to the power of 2 minus sine squared theta raised to the power of 2. As soon as you do that, you realize this looks like a famous identity, which is difference of squares, where you can write the first term minus second term times first term plus second term. And that's what I did here. By doing so, you again realize this is a Pythagorean identity, which is quite famous. That's probably the first thing that all of you guys learn when it comes to identities. So sine squared theta plus cosine squared theta is 1. You replace that, and after that, since on the right hand side I have only cosine terms, somehow I need to get rid of this sine theta. So sine squared theta, you can replace it with its equivalent value, again using the same identity up here, which gives me 1 minus cosine square theta. Do not forget there was a negative in front of it initially. After you expand it, the negative 1 and 1 is gone, and I have 2 cosine square theta, which is the right hand side, and I can stop there. In part B, I have to solve this equation, which looks a little bit challenging and difficult. However, you have to make use of what you found in part A. With simple comparison, you can see that theta over here is replaced with phi over 3. So therefore, the left hand side, instead of this expression, I can replace it with its equivalent value, the right hand side, which is 2 cosine square phi over 3. I'm given the domain for phi. So in order to make life easier, I'm gonna make my domain looks like exactly my argument, the argument of my trigonometric function. So I'm gonna divide everything by 3. So therefore, phi over 3 is between negative pi and pi. Let's get back here. I have to get rid of 2, divide everything by 2. I get cosine square phi over 3 is equal to 1 over 4. You take derivative to get rid of, you take square root from both sides to get rid of the power 2, and you end up with cosine phi over 3 equals to plus minus 1. Now, if you recall from the unit circle, this is actually a famous angle. The cosine of what angle is half, and that is pi over 3. The cosine of what angle is negative half, that is when you go backward pi over 3 from pi, and that is basically 2 pi over 3. Now, that is between 0 to pi. But my domain starts from negative pi all the way to pi. So for the positive half, there is another value which is negative pi over 3, also negative 2 pi over 3. So that's why I have these 4 values here. And then the last thing is left to do is to multiply everything by 3, because phi needs to be found, and that's the desired angle. Therefore, phi is either negative 2 pi, negative pi, pi, or 2 pi. What you could have done is that you could use another approach by introducing a dummy variable, such as calling this guy a, as most of you have seen in your textbook. But I think if you change the domain according to the argument of your trigonometric function, that would be a faster and easier way to get to the answer. And that is the answer for part B. And this is the final question for this paper. Thank you for watching the video. I hope you enjoyed it. Don't forget to like and share, and I'll see you in the future videos.